this is what the cumulative review is all about. So you're starting, I did this with a 7, 8, 9 class. My last teaching position was a 7, 8, 9 math. And what we would do is I just had a basket of notebooks. The kids would grab their notebook when they came in, and I just hand wrote the cumulative review on the board based on what the kids needed and what I thought was foundational. So the cumulative review also builds a routine, and it sets the tone for your class too. You know, you're obviously going to have lots of friendly welcomes, and they're happy. They're coming in, they're excited to come in and get to work. You wouldn't expect that, but I promise you they are. They're almost like the one day their notebooks weren't there. Like, what are we supposed to do? It's cumulative review. So it's a nice way to start your class. It builds mastery, because I always like to tell the kids, you do not have the luxury of forgetting this. This is not just us doing 10 pages in a math textbook and it's gone. This is a concept that you need to build on next year and the year after that. You do not have the luxury of forgetting it. You need to master this. So the other great thing is that it refreshes those older concepts that they might need to do the new learning that you're going to be doing with them that day. So you can be kind of sneaky and strategic and prime them with what they need to do your lesson today. So let's say you're teaching them Pythagorean theorem today. You might put in some square and square root questions there, right? A squared plus b squared equals c squared. They need to know how to do square roots and exponents, so you might just pop 1 or 2 in there to prime them and get them go, oh, I remember those things now. So you can be pretty strategic about how you do that. Now those foundational things, like Nicole was mentioning, those hills we will die on, you know, like how to multiply. We will put those in, because we're going to keep seeing them again and again and really build those strong neural networks in there so that it is really solid in their heads. Okay, so it builds mental math as well, because they're coming in and, you know, that could start with a multiplication question that they can recall, and if they can't recall, they can use reasoning to figure it out. We're building their confidence. They always feel pretty good about these reviews, and it gets that brain, that big, beautiful, activated brain, not that little tiny one with only a few places lit up. We're going to get all those things going. This is going to give you some pretty good information. You can watch your kids as they do this. You'll be like, oh, you forget that one? Don't worry, I'll talk to you later today. So you can kind of gather some information while kids are working on that. You can just mark it together. This doesn't have to be onerous and taken home every night and marked. Just mark it together. It's more for information for you and your kids. And it's more for instilling and building those deeper neural networks so that the kids are, again, don't have the luxury of forgetting something. And it's also a great opportunity to make some real-world connections. So if you're in a younger class, you might have a little cup as part of your mental math every day, and you might just go into your purse and throw some change in it. And then you can put it out somewhere, and the kids can come up and count it. So it could be as simple as that, right? So you can make some of those real-world connections in there. So here's a grade 6 example. These might be the 5 or 6 questions on the board when they come in. They'd get their notebooks or their whiteboards, and they would just start working. And the beautiful thing is, when you're done, help somebody else, okay, until we're ready, and then we can go through them. And then what would happen is, I can then, as the teacher, I can clarify some misconceptions. If they could start telling me that, you know, a tenth of 450 is 4,500. I can clarify that. Whoa, 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 you guys. You know, so it gives you that chance, or like, and again, different estimation points. Estimating the weight of something in the room, I would estimate the weight of this full water bottle. I want you to use kilograms. We could actually weigh it if we wanted to, or we could estimate. Or I might even say, what unit should I use to measure this? So then we have a grade 2 example. Okay, so again, notice that we're saying, we didn't just put up 9 subtract 5. We're using the math language. What is the difference between 9 and 5? They're like, oh, which one's the difference again? So you know, okay, we got to start using more of that language. That's subtraction. Okay, right. So this might be what it is. And you see, they're kind of those foundational things. These are not the things that are going to be a one and done. And keep in mind, and this is hard. You do not have to plan this meticulously. When I started doing this, I did. And what I found was, when I was putting it on the board, I was changing probably 3 to 4 of the questions every single day anyway. So what you want to do is think about, what am I working on in my class? What do I want to lead them to next? What are they always forgetting? And you know, right? They're like, oh, they always forget slope of a line. I'm throwing that in today. You know what your kids keep forgetting. So you really should never be using the same cumulative review questions from year to year. It should be based on your kids, what they know, and what you need them to know. And you're really going to think of those foundational things. And it does not need to take a lot of time. Legit, stand up there and think of them and write them. Or even better, get that bright kid who's always done her work about 30 minutes before everybody else to make one. And then put the answers down. And then you can edit it if you need to and change it up. Okay, so again, based on the kids. Always try to include some form of estimation. You're going to ask them all the questions. Okay, that's what I always say. They're always like, you ask all the questions, you guys. How much? How big? How far? How many? How do you know? Why? Okay, you will turn into the best question asker doing this activation. Okay, this is going to help build that number sense. And then I'm going to pass on to Carol to talk about some different entry points.
All right, everyone. We've been talking lots about getting that cumulative review and building that school community. One way that you can make sure all learners in your classroom, so when we support everyone in the classroom, there are 2 routines that you can do at the start of your class so that you're doing some cumulative review, but you're also making sure that everyone has an opportunity to participate. So one of those is open-ended questions. And Marianne Small is one of my most favorite math gurus. And she has a whole website devoted to open-ended questions. So with an open-ended question, there isn't any one fixed answer. There's a lot of different possibilities. So what we're doing is we're challenging the way kids think about math. So they can be solved in different ways. They can be solved different levels. And it empowers everyone. This is how we're going to be building up that number sense. So when we were having that conversation about can you teach number sense? Most certainly, but we have to make sure that the kids have room for their own mathematical thinking where they're making those connections themselves. So one of the good questions of the week from Marianne Small is, choose a reason why each number does not belong with the other 3. 60, 120, 123, and 240. So everyone think about which number does not belong. In your mind, which number does not belong? How many of you said 60 is the number that does not belong? Steve, why did you say that 60 didn't belong?
It only has 2 digits. The others have 3.
All right. So I'm building my knowledge of digits. 60 only has two digits. The rest have 3. Okay, who said 120 doesn't belong? Tammy, why?
Digits don't add up to 6.
Digits do not add up to 6. That's the one I usually pick, is 120. Because no one picks that one. So again, you're taking a look at the relationship of the numbers. 123, who said that one doesn't belong? Leanne, why?
It's not a multiple of 60.
It's not a multiple of 60. Someone else might have had a different reason, Anne? Right, it doesn't end in 0. Okay, who said 240 doesn't belong? Can anyone think of a reason? So as a teacher, I could extend your thinking here and say, we've got reasons for 60, reasons for 120, reasons for 123. What would be a reason for 240?
It's the only one over 200.
The only one over 200? Okay, so we have multiple answers. There's no one fixed answer here. Multiple ones. Actually, in another one, if you're looking at something from an older aged curriculum, how could you use 5 times 6 to help you determine what 8 times 6 is? And you could have students come up with a number of different ways. If you know what 5 times 6 is, how's that going to help you know 8 times 6? So open-ended questions allow everyone to answer. You could have a question where, Mary was given $50 to plan a birthday party. How many guests would she invite? And if she was going to make goodie bags, what would she put in the goodie bag? So you could have, she might only invite 2 people and give them a really good goodie bag, or she could invite, 50 people and only give them something little in their goodie bag. So lots of different entry points there. Something to check out is Marion Small. She's got 1 to Affinity as her website. Lots of great math things that you could use at the beginning of a class to do that review. The other strategy is called parallel tasks. And when we talked about knowing your students and knowing that some of your students might still be at the concrete stage, some of them still need the pictures, if we're doing something sequentially, or if you are moving into the abstract, you would have sets of tasks that are built around the same concept, but at different developmental levels. So kids then would determine which choice they were wanting to do, and you as the teacher could guide. If they always choose the easy one, you would be able to prompt them to maybe step out of that comfort box and try the more challenging one. But some of your kids will always need to have the one that's more simplistic, because just remembering where we are, knowing your students. So consider the readiness to engage in the concept. So you think about how you can actually word it on 2 different ways, and then create your question. So choice 1 here is choose a word problem that could be solved by multiplying 2 one-digit numbers. So someone who is in the early stages of multiplication, 2 one-digit numbers they could probably come up with quite independently. If I was more advanced, create a word problem that could be solved by multiplying 2 numbers between 10 and 100. So then I'm getting 2-digit by 2-digit multiplication. So I've challenged the learners, but I've still made it possible for all my students to answer, and then I could just follow it up with the same conversation. Another example would be about right angles. So what would be your choice? Solve the problem with the area, and then here's another one. You can't see there's 1 number here and there's 1 number missing. So they'd have to have a little bit more advanced math knowledge, but you could still talk about how to find the area of the triangle, and every student would have an opportunity to jump in where they're at. So parallel tasks are kind of nice too, because you don't have to have 2 choices, you can have 3, but everyone enters where they're ready. So 2 of my favorite routines.